Hey everybody, welcome back to the IGCSE Physics series. In this series, I'm going to break down all difficult physics topics so that you will achieve your desired target, desired score in your IGCSE exam. So, without any further ado, let's get into today's video. Well, today we are going to do about distance and displacement. Right. I know. It's not the most difficult, the most craziest topic in your IGCSE syllabus. But still, this will lay a good foundation for all your future lessons. So, let's study, let's learn, let's look at the distance and displacement. Well, imagine you have to travel between two cities. Let's name these cities as X and Y. So, the city X would be here, this X, and city Y would be there. Well, you know that we don't have straight roads. So, if the road is like this, you will have to travel by the car like that. But suppose you have a helicopter. If you have a helicopter, you will just travel straight away from X to Y. You can see that though on both occasions, traveling by car and traveling by the helicopter, you travel from X to Y, but still in two different ways. So, these are the examples of distance and displacement. Oh, what? I can't see distance and displacement. Can you? Of course, no. Let me label it. This is the distance. And this one is the displacement. What do you mean by that? What is distance? Distance is the length of the path taken. Very simply, the length of the whole route or the whole path that you went or took. But displacement is the shortest distance between the starting point and the end point. Let me tell it again. The shortest distance between the starting point and the end point. Now we have some understanding about what distance and displacement like. Now let's dive deep into see the different features or properties or the things that you want to learn on the distance. What is distance? As I told you, distance is the length of the path taken, and this is a scalar quantity. What do you mean by a scalar quantity? A scalar quantity has a magnitude, but this does not have a direction. So, you can measure the distance, you can get a value, but you can't show a proper direction. So, therefore, distance is a scalar quantity. It's a length measurement. So, therefore, you can use any unit that you use to measure the length. Well, let's take meters. It's the standard international unit. Other than that, you have kilometers, miles, maybe centimeters or millimeters too, if the length is very small. Now, when it comes to displacement is also a length measurement. So, you can use meters, centimeters, kilometers, miles, millimeters to measure the displacement. But you have to remember that displacement will always be a straight line. Why? The shortest distance between 2 points will always be a straight line. So, therefore, displacement will be a straight line. We could not measure the direction of distance, but in displacement, we can measure the direction too. So, therefore, it's called as a vector quantity. So, what's a vector quantity? A vector quantity is a quantity that has a magnitude and a direction both. So, displacement is a vector quantity. Other than that, it's a length measurement, similar to distance. The same units are used to measure both. Right? The international unit is the same. The difference is distance is a scalar quantity, displacement is a vector quantity. Okay. Since this is understandable, let's go into an example and let's see whether you can understand the example. So now we are looking at Tom's story. Tom has his house here. This is Tom's house, Tom's place. And this is Tom's school. Okay, this is Tom's path to school. This is Tom's house, this is Tom's school. So Tom cycles 4 kilometers and then turns and travels 3 kilometers. Well, so if somebody asks you what is the distance that Tom travels, you would easily say that, okay, Tom travels 4 and then he goes 3. So what's the distance? Distance that the Tom travels is 7 kilometers. There is no doubt about it. Easy. But then, what's the displacement? So, if you match house and Tom's school, you will get this line. This is the shortest distance between Tom's starting point and Tom's ending point. That is the house and the school. Well, how do you find it? It's easy. You will have to use a bit of maths for this. If this is 90 degrees, well, of course, it will not be exactly 90 degrees in my drawing because it's on the whiteboard. But let's suppose it is 90 degrees, so he moves 3 and he moves 5. So if you use the Pythagoras theorem, which I am not going to show here, you will get this distance as 5. So what's the displacement? The displacement that thumb makes is 5 kilometers. Well, yeah, the displacement seems shorter. Yeah, good. So once again, distance is the length of the path taken, and displacement is the shortest distance between the starting point and the end point. Okay. Let's look at another example. Imagine there is a person. He moves from A here to B. But while he is moving, he passes C. So, from A to B, you have 10 kilometers. Oh, so long distance. And then from B to C, you have 4 kilometers. So, what's his path? The man moves from A to C, then to B, and returns to C. So, man moves from A to C, to B, and to C again. Let's calculate this man's distance and displacement. So, what's the distance? Distance is equal to the length of the path taken. So, the man went from A to C and to B, and then came back to C again. Well, A to B you have 10 kilometers, and on his return journey he came 4 kilometers. So, altogether this man had traveled 4 plus 10, which is equal to 14 kilometers. 14 kilometers. But what's the displacement? Where did he start? He started here at A. Now where is he? He is at C. So what's the shortest distance between the starting point and the end point? Always remember, to get the displacement, we have to consider the starting point and the end point. So the starting point is here, end point is there, and this is the difference between 10 and 4. So you will see that this distance is 6 kilometers. So the displacement of this person is 6 kilometers.